Hey, welcome back, everybody. Taking a look here at Savas Algebra 2, Lesson 7-6. Happens to be the sixth problem I've asked you to do. You got a table of data, the months and the rainfall. And we're supposed to come up with, if you look at your choices for answers over here, we're supposed to come up with a model, an equation that's in cosine that will fit that data. Not sure how this is going to go since it has been a while. I have set this all up in Desmos to save you a little bit of time. So first thing I did over here is I went over to Desmos and I entered all that data into this table. The month, like 2 would be January, the 5.83 would be 5 and 83/100 inches. I think it was rain. And so if you don't remember how to enter a table, the plus sign right up here in the table, we'll add the table there. And then type in all your data. For the general equation that we just saw, they're in the form A, the amplitude, B is the frequency, how many times the cycle completes in the normal 2 pi. C, your phase shift to the left and right, or horizontal transformation, and D, your midline, or sometimes I call that sinusoidal axis. A few more syllables there. And so for your midline D, if you just take the highest point of your data and the lowest point and find their average. So my Y's, the lowest point was the 0.16, and my highest rainfall was this 778, and then I added them together divided by 2. So if let's take off from here. I got another graph turned on somewhere down here at the bottom. Turn that off. What else is on? There's a sinusoidal, my final one, I think. So let's get back to the top where I did my first step. And then I put that in. So what that is it put my middle line, my midline, that's going down this axis of the two. If you look at these green dots, it's kind of halfway in between those. So I've got my sinusoidal axis or midline in at the 4.15. Now my amplitude, the A value, stretch factor out in front, if I take the maximum minus the minimum, 2 points, and subtract those and then divide by 2, that's finding how far the graph goes above and below the midline. So if you go from this midline and you go up to the highest point, or from the midline down, there's your amplitude. So that's what this is finding. So we're finding the amplitude of the 3.855. So let's see, let's put that in with our midline and see if we're getting closer here. I can get a hold of that. Let's see, let's move this over. So now if you see with those two combined, let's take all this other stuff off. So now it looks like it's going the amplitude up and down the right heights and my midline down through the middle. And so then if we go to look for the frequency, how often does it complete a cycle? Our normal period's 2 pi. So this data is yearly. It's yearly data. So we're going to complete a cycle in 12 months because the whole year starts over, cycles start over. So we take our normal period of the 2 pi down here, this 2 pi, and we divide by the 12 months. So that means we're going to be completing a cycle, our period, our frequency of pi over 6. So now if we go and put that pi over 6 in front of our x value here, and so if I come back up here, let's turn that one off. Now we're up to here. And now if we just can move this thing over to the right a little bit, get this low point over to this low point, I think we've got it. So lastly, And for this one, they say just go ahead and sort of like eyeball it. So if you look here, I feel like this is actually more like these are increments of 1. So I feel like that's closer to 2. When I looked at the choices we had, though, we've got a 1 here. So if you moved it to this point right here, so that's just a 1. And so that's what they're saying to do. Now, I did throw in here at the very bottom, what if we just ran a regression on this total thing? So let's just take a look at what, if I ran this regression, how close is it to what we have? So it's not off by much. So I would describe above as doing it by hand, and then this regression, might be faster. Looking down here, your regression analysis right here. It's not great, but it's pretty good. It'll give us a faster estimate for that equation to get the graph that does the best job of coming close to all those points. Anyway, there's 2 different ways to work that. Let's see if we go and select this. I'm not sure if I'm going to be able to do this. It might tell me I have to start all over. I think we had this one. And let's see, what all did we have when we were just talking about that? We had we averaged and got our midline to be that, and I believe that was our coefficient for our amplitude. These 2, they forgot to divide by 2, it looks like. And then we moved it to the, so let's see. I have a feeling it's going to tell me we got to log back in. So that was okay. The next question, the average of all 12 rainfall amounts would be about blank is the midline value is, what's that pull down choice right there? Is greater than. So the average of all of them, oh, let's see, I've got that in my Desmo. So if I just do a mean of the Y1 column, that should tell me what I have. So by having it all typed in here, mean of Y1, so 3.2-ish, says type integers or decimals round to 3 decimal places. Oh my goodness. That's 3 decimal places. 3.228. 3.228. Decimals, add them all up and divide by the 12 for us. And that is, what was our midline again? The midline right here, the 4. So this is less than the midline value of the 4.015. All right, let's check that. Something it doesn't like. Let's see again. The average of the 12 rainfall amounts. About average and my Y. My Y were my rainfall, Y1, that's the column heading. And when I did let's put this up closer to the top here so I can see it. Next to my data, the mean value, the average, 3.228, is less than my midline, because my midline was the 4.015. My 3.228 is less than the midline type. I have no idea what they want there. Let's just see what they said. 3.236. So I don't know where they're getting the 3.236 unless I have a typo in my data, but I thought I checked that 2 or 3 times. The 6.46, 5.83, 6.46, 5.83, 4.84, 2.52, 1.81, 0.79, 0.29.16, 0.59, 2.28, 5.39, 7.87. So my data is right in that table. And the question, again, said the average of all 12 rainfall amounts. I don't know why that would be different. I don't know where the 3.228. I mean, Desmos is going to do that correctly anyway. So you see what they're, I don't know how they're coming up with that one, but anyway, then the graph that would match that one. So your midline going down there across the 4.14, something like that. This one's out because that's nowhere near the midline. And then here, let's see, midline here is 4 point. Well, it never goes below the x-axis over here. And then this one's going, I think that high point over there is a little too far to the right. This low point at the 9, this low point at the 7. If I look over here, I think it's closer to that 7. So that would be this speed. And with that, hopefully that gives you a little bit of an idea how to do that problem. So good luck, everybody. Hope you're having a great day. Again, as I always tell you, whatever you do, just don't give up. You can figure this out. Search different YouTube videos on, this is modeling sinusoids or modeling sine and cosine graphs for real life problems. All right, have a great day, everybody.